Hello. Please make sure that you are only watching this once you have attempted the worksheet on your own. This is a hard worksheet, but it is really good practice of a lot of the skills that we've been working on the last few days. If you only need certain problems, feel free to fast forward to the ones that you need. So here we go. Number 1, x to the 4th minus 8x squared minus 9. No GCF, it is a trinomial, so let's get x squared minus 9, x squared plus 1. And remember, the last thing that you should do for every factoring problem is make sure that each factor is set, that it can't be factored more, and in this case, x squared minus 9 can be. And we are left with x minus 3 times x plus 3 times x squared plus 1, and that is that. Okay, number 2, I kind of run out of room on the screen, so I'm just going to write it a little bit over. But this is the same as 4 cubed plus 3a cubed, all cubed. Therefore, we have a sum of cubes, and following our formula, we have base plus base. We have 4 plus 3a cubed. First base squared, therefore 16, minus our base times base, so 4 times 3. I'm going to just write that as 12a cubed, always positive, so plus. And then we've got our 3a cubed squared, or 9a to the 6th. You don't have to, but I am going to go ahead and rewrite this as 3a cubed plus 4 times the quantity of 9a to the 6th minus 12a cubed plus 16. Can't take a GCF out of 3 and 4. Can't take a GCF out of 9, 12, and 16. Let's just see if I can factor this. Remember, we shouldn't be able to. Perfect squares. If I did 3a to the 3rd and 4, I'd have something that is not negative 12. Okay, number 3 is like from our notes on Friday. I'm going to divide each of these by the GCF of x. I'm going to kick x out. And remember, I now subtract my exponents. 2a plus 1 minus 1 leaves us with our base of x to the 2a plus x to the a minus 6. We now have x times the quantity of x to the a plus 3 and x to the a minus 2. Okay, number 4, x squared minus 6x minus 216, pretty basic problem, trinomial. Only issue here is we're dealing with a larger number of negative 216. Therefore, think about the factors of negative 216 that add to negative 6. And they should be x, whoop, didn't mean to do that. We get x, still on the wrong thing. There we go. X, no, what happened? Sorry about that. Change colors, move position. We've got x minus 18 and x plus 12. Negative 18 times 12 makes 216 and adds to negative 6. Voila. Okay, x to the 6th minus 1. This is a situation where I could do squares or cubes first. And remember, I'm going to do squares. Therefore, I'm going to do x to the 3rd minus 1 times x to the 3rd plus 1. I have factored using difference of squares. And by me doing that first, I now have two either sum or difference of cubes. So I'll deal with our difference first. Base minus base. First base squared plus their product plus second base squared of 1. And then that x cubed plus 1 should look very similar. X plus 1. I'm just going to write it below because I'm running out of room. And we'll have x squared minus x plus 1. Each factor is set, and we're left with this as our answer. X minus 1 times x squared plus x plus 1 times x plus 1 times x squared minus x plus 1. Okay, number 6, x to the 9th minus a to the 15th is difference of cubes. I'm going to rewrite that as x cubed minus, rewrite that as x cubed cubed minus a to the 5th cubed. Therefore, leaving us with x cubed minus a to the 5th times that quantity of x cubed squared, or x to the 6th, plus base times base, therefore that's x cubed a to the 5th. And then we got a 5th to the 2nd power, which is a to the 10th. Therefore, x cubed minus a to the 5th times the quantity of x to the 6th plus x cubed a to the 5th plus a to the 10th. Feel free to pause at any time. Okay, number 7, I got 6 terms, so that's going to be factoring by grouping. And it doesn't look like things are arranged all that nice yet. So let's see. I'm going to do a squared minus 2ab. Since I've got that ab, I'm going to pick up the b squared. So I've got that, that, and that. Oh, let's see, doesn't matter. I guess I'm going to go negative y squared plus 6xy minus 9x squared. I can at least factor my first 3 terms to be a minus b quantity squared, but I'm going to factor out a negative 1, just like our notes from the next trinomial, leaving me with y squared minus 6xy plus 9x squared, which now is a perfect square trinomial. And I'll still have that a minus b quantity squared minus now the quantity of y minus 3x quantity squared. And now I've got a difference of 2 squares, leaving me with the quantity a minus b minus the quantity of y minus 3x times the quantity a minus b plus y minus 3x. You can go ahead and drop the parentheses, distribute the negative if you want. I'm just going to leave it as this. There are no like terms. Okay, next one, in my opinion, is, I think, the trickiest one of the worksheet. Oops, ignore that those circles did not follow suit. Let's see. Whatever. Okay. Hopefully you tried this on your own, and it probably took quite a while if you got it, just playing around with all different groupings, and you notice, like, no matter what you do, for probably quite a while, nothing worked. The trick is to break it into, first of all, even exponents. Change color for this one. Therefore, I've got a to the 4th minus a squared minus 12. Now I'm going to put my odd degree. Therefore, minus 4a cubed plus 16a. And I'm going to do this as a 3 and a 2. Well, a to the 4th minus a squared minus 12 is a trinomial. That can be factored into a squared minus 4, a squared plus 3. And then from my next 2 terms, I'm just going to take out the GCF of negative 4a, and I'll be left with a squared, look at that, minus 4. Now, I see that I have this GCF of a squared minus 4 times what's left, the quantity of a squared plus 3 minus 4a. I'm going to run out of room. Well, let's see. A squared minus 4 is a minus 2, a plus 2. A squared plus 3 minus 4a is really a squared minus 4a plus 3. I'm putting it in descending order because, voila, I can now factor it. I've got my a minus 2 times a plus 2. Numbers that multiply to 3 and add to negative 4 would be a minus 1 and times a minus 3. And we are left with a minus 2 times a plus 2 times a minus 1 times a minus 3. Tricky one. Trickier than your quiz. Okay, number 9. 2y plus x squared minus x minus 4y squared. Well, let's just play around with what we should be grouping. You may have tried grouping your y's and then your x's, but what you notice is as soon as you group one of them, let's say you group your x's, and you get that x squared minus x, you take out an x, you're left with a factor of x minus 1. Well, there's no way I'm going to get an x out of y. Therefore, you want to kind of do mixed pairings, and which means I'm going to try x squared minus 4y squared. I chose those two to get together. Once again, I'm mixing it, but then also they both have those squares. Then since I chose x first, I'm going to go ahead and do the minus x and then plus 2y. X squared minus 4y squared is the difference of squares of x minus 2y times x plus 2y. And that's our, we just lost power. And then I've got minus the quantity of x minus 2y. Looking at GCF now, we've got that x minus 2y. Take that out, we've got x minus 2y times the quantity of x plus 2y. Oh, be very, very careful here. You need to have a placeholder. Do not just stop it at that, because if you were to distribute it back, you'd never get back to that minus the quantity of x minus 2y. So don't forget to put a minus 1 as a placeholder. Therefore, x minus 2y times the quantity of x plus 2y minus 1. 10 is a grouping. Just looking at it, looks like a 2 by 2, and it looks like you can do it in a few different ways. I'm going to leave it as is, and I'm going to take out, for my first two terms, I'm going to take out an m squared, leaving me with x minus a. From my last two terms, I'm going to take out, well, I need to get that x minus a, therefore I'm going to take out a negative n squared, leaving me with x minus a. Good, I've got my GCF of x minus a, and then I've got m squared minus n squared. Always check to see if you're done. We are not. X minus a times the quantity of m minus n times m plus n. We had a difference of squares within there. Okay, number 11. Let me zoom in a little bit. I see that GCF of x minus y in both of our terms, giving us x minus y times the quantity of 4 times x minus y, still squared, minus 1. What some people might do is they might multiply this all out and work from there, but what I notice is that 4 is a perfect square, x minus y is a perfect square, and then 1's a perfect square. Therefore, really, this is just a difference of two perfect squares. If you need to write it, x minus y times that quantity of, really the quantity, I need 2x minus y all squared minus 1 squared. Sorry, that's really sloppy. But now I have a difference of squares, which means I will have x minus y times keep me do bracket, times the quantity of 2 times x minus y minus 1 times then 2 times x minus y plus 1. And I'm okay if you leave it like that. So that's really weird looking. But we've got x minus y times that quantity of 2 times x minus y minus 1 times 2 times x minus y plus 1. They're conjugates. If you want to simplify that a little bit further, I don't have any room, but I would do x minus y times 2x minus 2y minus 1 times 2x minus 2y plus 1. Okay, this one's pretty straightforward. Once again, when I'm grouping, if I were to group my x's, yeah, I could take something out, but my y's aren't going to have an x in. Therefore, I'm going to rearrange this to be x cubed plus y cubed plus x plus y. Okay, that x cubed plus y cubed is the sum of cubes, x plus y times x squared minus xy plus y squared. And there's nothing to take out of x plus y, therefore it's just going to be plus the quantity of x plus y, which is totally fine because we still have a GCF of that x plus y. And very, very important here, once again, people often want to forget about that y plus 1. We need to have a placeholder of plus 1. Otherwise, when I distribute back that x plus y, I would never get back to my original. Therefore, I have x plus y times x squared minus xy plus y squared plus 1. I apologize that this is so messy. There's no, no zoom in feature like Notability, so it does not give you an option to be as neat. And as soon as my hand hits the screen, it goes crazy. So I'm writing very strangely. Okay, 13, I would probably let u equal x plus y. And now we've got u squared minus 23u plus 76. Two numbers that multiply to 76 and adds negative 23 would be u minus 19 and u minus 4. But don't forget to put back in your x plus y. Therefore, the quantity of x plus y minus 19 times the quantity of x plus y minus 4. You can drop those in parentheses, but you don't have to. Oops. Okay, next one, another grouping. I'm going to try just leaving it as is and taking out an m cubed. And we'll times x cubed minus 8. And then from our last two, I'm going to take out an n cubed, leaving me with x cubed minus 8. Therefore, we've got our GCF of x cubed minus 8 times m cubed plus n cubed. And we've got a difference of cubes and we've got a sum of cubes. Not all that difficult, just a long problem. Therefore, giving us x minus 2 times x squared plus 2x plus 4. And then we'll have m plus n times m squared minus mn plus n squared. Okay, we've done some like this in class. Many different ways. You could multiply it all out, but what I'd rather see you do is realize that x squared minus 1 to the second power is really the quantity of x minus 1 times x plus 1 squared minus that x minus 1 squared. So better yet, using our exponent rules, that's really x minus 1 squared times x plus 1 squared minus x minus 1 squared. We now have that GCF. Have x minus 1 squared times the quantity of x plus 1 squared minus that placeholder of 1. Now you've got some options. You could go and multiply out x plus 1 squared and then subtract 1, but what I noticed once again is that x plus 1 is a perfect square and 1 is a perfect square. Therefore, I'll have x minus 1 squared. Then I'll have times the quantity of x plus 1 minus 1 times the quantity of x plus 1 plus 1. Totally ran out of room, so I'm going to squeeze it in down here, giving me x minus 1 quantity squared. Then I have x plus 1 minus 1, therefore times x. And x plus 1 is our x plus 2. Pause at any time that you might need. A few different ways of doing this one as well. I'm going to take 3 times 2x minus y. I'm going to leave that as is. And what I notice is that y minus 2x is just the opposite. Therefore, I'm going to factor out a negative from that, and I'll be left with negative b times negative y plus 2x, or better yet, 2x minus y. I now have that GCF of 2x minus y times 3 minus b, and that's that. Okay, 17. X squared minus a squared minus 6x plus 9. I see 4 terms. I see that I have x squared and a 6x. If I do 2 and 2, there's no way things are going to match up. Therefore, I'm thinking x squared minus 6x plus 9, and then all that minus a squared. Well, that gives me x minus 3 quantity squared minus a squared. Well, that's a perfect square minus perfect square, difference of two perfect squares, leaving me with x minus 3 minus a times x minus 3 plus a. Okay, 18 I told you ahead of time was one of those problems we have to add something to. To make a perfect square trinomial, we need the middle to be 4. Therefore, I'm going to add x squared y squared, which means I need to also subtract it, leaving me with x to the 4th plus 4x squared y squared plus 4y to the 4th minus that x squared y squared. Well, now we have a perfect square trinomial of x squared plus 2y quantity squared, and I might as well rewrite that as xy quantity squared. Now we have a difference of squares, which turns into x squared plus 2y minus xy, and we've got quantity of x squared plus 2y plus xy. I could rearrange it, put that negative xy between the two and the xy between the two, but it's not going to change the factoring. 19 similar. To make a perfect square trinomial, we need to have 18. Therefore, add 16x squared y squared, which makes sense because we're subtracting 16x squared y squared, which is a perfect square. We will now have x to the fourth y to the fourth plus 18x squared y squared plus 81 minus 16x squared y squared. Well, that turns into x squared y squared plus 9, all quantity squared, minus, I'm going to rewrite that as 4xy quantity squared. And I now have a difference of two perfect squares. We've had a lot of those on this worksheet. And we get the quantity of x squared y squared plus 9 minus 4xy times its conjugate. Quantity of x squared y squared plus 9 plus 4xy. Finally, we've got a difference of cubes. This is really x to the a all cubed minus 3 cubed. Therefore, x to the a minus 3 times, well, x to the a squared is just x to the 2a plus 3x to the a plus 9, and that is that. Hope you guys have a wonderful weekend, and let me know if you have any questions. Bye.